everyone, welcome to Tutor Connect. I am Iresha with another chemistry lesson for you. Today we are going to talk about bondings in chemical reactions. So without any further ado, let's get to the lesson. So bonding in chemistry, we are going to first talk about ionic bonds and their properties, and the next thing we are going to talk about is covalent bonds. We are also going to talk about metallic bonds, and those are the contents for today's lesson. So what is a chemical bond? It is actually an attraction. Bond is an attraction. Since this is chemistry, the attraction is between atoms and ions. And now we will talk about ionic bonds. Ionic bonds are, as the name suggests, formed between two ions. Here you can see plus ion and this is a minus ion. These are opposite, and opposite charges attracts, therefore there will be an attraction or a bond in between these two ions. So how is this plus ion is formed? Here you have an atom. This side you can see atoms which are in the neutral state. What you do is you remove an electron from this atom, which will give you a plus charge. On the other hand, if you want to form a minus ion, what you do is you add an extra electron to the atom. Therefore, the negative charge will be higher, and the overall charge of the atom, or now we call it an ion, will be minus. Now you have a plus ion and a minus ion. In between these two you have an ionic bond. So you should remember that when forming an ionic bond, it is always between two ions which are having opposite charges. Okay. So these are some properties of ionic bonds. Compounds that have ionic bonds have high melting and boiling points, and almost all of them are soluble in water. An example for this one is salt and sodium chloride. So almost all of them are soluble in water, and they conduct electricity when melted or dissolved. This is very important. It should be melted or dissolved. As I was telling you, compounds with ionic bonds, they conduct electricity very well only under these conditions. They have to be either melted or dissolved. If they are in the solid state, you cannot conduct electricity. Moving on, now as I told you, most of the salts, the most popular one, sodium chloride, is they have ionic bonds, and they normally are present in ionic lattice. These are very large, giant ionic lattice. This is how you represent it. Each sodium ion is surrounded by 6 chloride ions. You can see here, if you represent chloride ions with these green color circles or balls, one of these ball is surrounded by 6 of these purple color atoms. So these are actually sodium, and each chlorine ion and each sodium ion is surrounded by 6 other opposite charged atoms or ions. Since they have a charge, you can call it an atom. Let us now see how sodium chloride is formed. So here you can see the sodium atom, here you can see the fluorine atom. Only the outer shell is represented here. You can see 281, which is the electron configuration, and in the outside, the outermost one, you have only one electron. Just like that, here the electron configuration is 2, 7. On the outermost shell, you have only 7 electron. So you know from the last lesson that these are not stable electronic configurations. So what you can do is you can donate this electron to the fluoride ion, fluorine atom, which will give you a minus charge due to the extra electron. And now This has a plus charge because it donated 1 electron. So, the overall positive charge is higher here. So, now you have a plus ion and a minus ion. Together they will form a bond because there is an attraction between plus and minus charges. Let us now see what a covalent bond is. This is a different type of bond. There is only one difference. These also involve electrons. The only difference is they do not donate an electron completely. What they do is they share the electron. For example, this is the ammonia ion, which can be represented in this form, NH3, and you can see that this nitrogen atom have 1, 2, 3, 4, 5 electrons on the outermost shell, while all of these hydrogen atoms they only have 1. So, to gain a stable electronic configuration, what they can do is share these electrons. So, hydrogen atoms can pretend as if they got 2 electrons, and this also the same and this also the same. Having 2 electrons in the outermost shell means they have a stable electronic configuration. On the other hand, nitrogen atom also can pretend as if they it has 1, 2, 3, 4, 5, 6, 7, 8 electrons, which is also a stable electronic configuration. This is another example, carbon dioxide. This is how you represent the carbon dioxide. Carbon atom, you have 1, 2, it is represented in black color, 1, 2, 3, 4 electrons on the outermost shell, and on the other hand oxygen 1, 2, 3, 4, 5, 6, and this right here represents 2 bonds. This is a 1 bond, this is a 1 bond. Both of these bonds they involve 4 electrons. So, in fact, at the moment carbon is sharing its 2 electrons, while oxygen is sharing these 2 electrons. So, carbon now have 8 electrons in the outermost shell, which is a stable electronic configuration. Likewise, oxygen also now has 1, 2, 3, 4, 5, 6, 7, 8 electrons, which is a stable electronic configuration. This is another example. Here you can see the nitrogen molecule. Nitrogen molecule is made out of 2 nitrogen atoms, just like we discussed earlier. Here you have 3 bonds. So, in these 3 bonds, this is a 1 bond, this is another bond, this is another bond. All together they are sharing 6 electrons. So, nitrogen now has 1, 2, 3, 4, 5, 6, 7, 8, which is the stable electronic configuration. And now we will see some properties of covalent bonds. Compounds that has covalent bonds has these following properties. They have lower melting and boiling point compared to the ionic bonds, and these molecules are not flat and they do not conduct electricity. This is very important, since there are no free ions, they do not conduct electricity, and they often dissolve in non-polar solvents. Unlike ionic bonds, they normally dissolve in polar solvents. This is the exact opposite. Okay. Now, we will see another type of bond which is called as metallic bond. This is an interesting type of bond. Here you can see plus ions, and these blue color ones are electrons. So, these plus ions, they are certain kind of metallic ion. For example, you can say take sodium, magnesium, or whatever the metal you like. So, this is how a metallic bond is formed. Plus ions are these are metal ions, and these electrons are actually delocalized electrons from the outer shells of the metal. So, they are like dipped in a shell of electrons here. And some properties of metallic bonds are they have high melting point, and they are also malleable, meaning you can make them into any shape without breaking them, and also they are ductile, you can make them into wires. And you should know that metals are normally good conductors of heat and electricity. They conduct both heat and electricity really well. A good example for this is we use metals for cooking purposes. This is a good example where you use the conducting property of metals. And electricity also, most of the wires, for example copper is mostly used to make wires. And now we will go back to the whiteboard for an example. Here we will do the H2O. Okay. So, H2O is a well known solvent. What kind of a solvent is this? Is this a non-polar or is it a polar one? Is it non-polar or polar? So, this is how you can determine that. Normally polar ones are they have their charge is distributed. For example, if you say oxygen, hydrogen, hydrogen, this is how you represent the H2O molecule. So, as you know, oxygen is highly electronegative. This oxygen atom, they like electrons. So, the electron cloud of this molecule is pulled towards this oxygen atom. Therefore, this oxygen atoms gain a slight minus charge, while these hydrogen atoms gain a little bit of a plus charge. So, this is actually a polar solvent. So, since this is polar, as we discussed earlier, compounds that have covalent bonds do not dissolve in water. For example, if you take CCl4, which has covalent bonds in between them, is insoluble in water. You can have two layers if you add CCl4 into water. Here, if you have water, you can have a CCl4 layer here. Those are immiscible. Okay. And also, if you want to represent the H2O molecule using covalent bonding, what you can do is oxygen atom, and you can represent the oxygen outermost layer using the electronic configuration. Oxygen is 8, therefore, you have 2 and 6. This is the electronic configuration of oxygen. So, you have this is actually 6. It should be 6, altogether you should have 8. So, you should have 1, 2, 3, 4, 5, 6. And to gain a stable electronic configuration, oxygen needs 2 more electrons. How it is done is oxygen reacts with 2 hydrogen molecules. Hydrogen molecules, on the other hand, has one electron in its shell, and this is hydrogen. Here there is another hydrogen atom. So, this is the electron of this hydrogen atom. If you represent H2O like this, now oxygen can pretend as if it has 1, 2, 3, 4, 5, 6, 7, 8, which is a stable electronic configuration, and hydrogen also has 1, 2, which is the electronic configuration stable one for the first shell of an atom.